Hey, y'all, it's the time we've been waiting for. It is quadratic equations. Well, not quadratic equations, but quadratic function time. It is chapter 9. This will be the last chapter that we will go over. We will not get to statistics. So next year, your teacher's going to be like, did y'all get to statistics? And be like, nah, we got to the important stuff. Not that statistics is not important. It's just not tested as important. Whatever. Y'all will make it up next year. But we are in chapter 9 and we're going to learn everything there is to know about the quadratic function as in terms of A, B, and C. Now, if you've seen this before, it cracks me up every time I get here, and the last chapter dealt with this over and over again. And then when I get here, y'all are like, oh, this is brand new. No, it's not. It is not new. All right, let's get to work, people. Good to see y'all. Happy Monday or Tuesday or Wednesday, whenever you're watching this video. You know how some of y'all do. You don't do your work on time at all. Oh gosh. Okay, so this is the graph. This is not. This is on purpose. Because yeah, I can't talk. It's late, y'all. I just want to let y'all know it's late. Okay, I'm gonna try to do this to the best of my ability. Let me move me down here. All right, it says the trinomial ax squared plus bx plus c. We've seen this before. We've seen this before, that we have been factoring, yes, when in an equation y equals ax squared plus bx plus c forms a function called a parabola. So we have seen this wonderful expression before. That's what we've been factoring the entire time. Y'all, that's what we've been factoring. Yeah, that's what we've been factoring. Now it's in the form of an equation, and this is the standard form of that equation. Standard form. Now you will need, I don't think you need paper and pencil for this lesson. I don't think so. Because I'm gonna give you the cheat sheet and you'll be fine. All right, so a parent function. Okay, so y equals x squared is a parent function. A parent function is the simplest function of a family of functions. Let me read that again. A parent function is the simplest function of a family of functions. For the family of quadratic functions, y equals ax squared plus bx plus c is the simplest function of this form is y equals x. I cannot read right now. It says for the family of quadratic functions, y equals ax squared plus bx plus c, the simplest function of this form is y equals x squared. There shouldn't be a period there. That's why I was throwing me off, that period. So y equals x squared is the simplest form of this function right here, which is in standard form. All right. And so the simplest form of this function is called the parent function. You know, we had a parent function for exponential functions. Ooh, that's a good extra credit question. What's the parent function for exponential functions? Y'all got to excuse me. I've been talking all day. I've spent 3 hours making videos. It's crazy. And so that's one extra credit question. And then this is the next one. Why is the function curved? Now, the curve is called a parabola. It's called a parabola. So this right here, this is a parabola. So why is it curved? That's an ed puzzle. Oh, let me give y'all this hint. You have to look at the table. The table may help you, but that's all I can tell you. But you have to tell me why it's curved for 2 points. All right, well, this is why it's curved. It's curved because you are squaring the number. So you put your input of -3 is 9, but your input of 3 is also 9 because we're saying a negative times a negative is a positive, and then a positive times a positive is a positive. So you see that 3, pick a different color. So you see that 3, 9 here, and you see that -3, 9 there as well. You see -2, 4 here, and you see -2, 4 here. It doesn't form a V. You'll see later on that quadratic functions form a U-type shape. And we did this back in the function project, but you know, we ain't talking much about it. So it's curved because you're squaring a number, and a negative times a negative is going to give you a positive. So you end up getting the same number on both sides of the parabola. Y'all see that? Woohoo! All right. I'm gonna try to do my good teaching today, just for y'all, because no gaps, no gaps, no gaps. So we're going to examine each part of the standard form of the quadratic function. So we're going to look at a first. Oh, I didn't even pick red. Look at there. He must have knew. And then we're going to go to B, and then we're going to go deal with C next. So let's deal with A. Now, A has several different functions that happens with A. So, as we look at y equals x squared, which is this function here, this is the purple function, and then y equals negative x squared, what is happening? First of all, we say that it forms a U shape, right? That's what we said. A parabola forms a U shape. But what is happening when A is positive? When A is greater than 0, which means it's positive, what happens to the quadratic or the parabola? How does the parabola look? And then what's happening with the parabola when A is negative? You're going to put that in Ed Puzzle. I'm going to have so much to read of y'all responses. I don't know if we're going to put all these in Ed Puzzle. It's just so much reading. Like, it's 50 of y'all. It's not gonna happen. All right, so we're gonna do it now. What's happened when A is negative? What happens when A is positive? All right. Okay, so when A is positive, that means greater than 0. Greater than 0, you have a happy face. Yay! When A is negative, that means less than 0, you have a sad face. Yeah. So the parabola opens up when A is positive, and then the parabola opens down when A is negative. Negative down, positive up. All right, simple as that, y'all. Happy face, sad face. If that's the way you want to remember it. Go ahead with your bad self. All right. A has another function. Now let's look when A is greater than 1. Now I would pick all these colors, and maybe I'll get a little fancy with that. We'll see. All right, so do I have them all up here? Something close to them. Yeah, something close to them. So when A, this is y equals x squared is right here. I might not have to do that. And then we're gonna y equals 2x squared, then y equals 3x squared, and then y equals 10x squared. What is happening with the parabola? Now, the parent function is in red. That's in red. But what is happening as A becomes greater than 1? What's happening? Okay, look at green, then orange, then purple. All right, so you should see, I'm not doing Ed Puzzle. You should see that the parabola is becoming narrower, right? You start off with here, with this, and then it gets smaller, narrow now. Okay, it becomes more narrow. And so this is called a vertical stretch. It's called a vertical stretch because when you stretch something out, it's getting skinnier. Like if you think about a rubber band, you start off like this, and maybe y'all can't see me stretching and all that stuff that I'm doing right here. If you start with a rubber band and you stretch, it gets narrower, more narrower. So it's called a vertical stretch. When A increases, becomes greater than 1, we have a vertical stretch. Okay. So that's why it's called a stretch, because the parabola becomes more narrow when A is greater than 1. There are several things y'all got to remember, but again, I'm going to give you a cheat sheet at the end. All right, so now let's examine A. We're still on A. We are still examining A. What happens when A becomes less than 1? Okay, so we got the parent function. The parent function is here. And then 1/2 x, y equals 1/2 x squared. Then y equals 1/3 x squared. And then y equals 1/5 x squared. What happens when A is less than 1? Okay, or becomes smaller? Smaller than 1. All right, we can see that it widens. It widens. It widens. This is called a vertical compression. I usually get confused on these because when I think compress and stretch, My mind, I don't know. I think opposite. So when you think about a vertical compression, I'm trying to talk, y'all. Forgive me. A vertical compression, you think about something being compressed, so it's flattening out. It's flattening, 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 flattening. You see that? So that's what this is. This is becoming flat, flatter, 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 flatter. So it becomes wider, 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 wider because it's flattening out. I like this little speak to y'all and then look at y'all and then back at the lesson. I like this. Okay, so it's a vertical compression. All right. And now let's look here. So let's review A. So we're all we've been doing is talking about A for 10 minutes. Jesus. Okay, so let's just talk about A. A does what? When A is greater than 0 or positive, it opens up. When A is negative, less than 0, it opens down. When A becomes greater than 1, it becomes a vertical stretch, which means it becomes more narrow. When A is less than 1, we have a vertical compression, which means A, and I know it's cut off at the end because I didn't realize I had it way down there. That it means it's a compression because A is becoming less than 1. All right. So now we're going to deal with C. And let's see. Let's see what C does. C is green. And you're somebody you're like, why you skip B? It's because B is a little bit more difficult, y'all. All right, so C is right here. C is green. We have y equals ax squared, which is this is our parent function. Why? Because this is the simplest form of a quadratic function right here. And I'm saying, what is C? Every dot that you see represents C. So this is the red dot of C. This is the green, Jesus Christ. This is the orange dot of C. This is the green dot at, I should probably give y'all the numbers, -1. And this is the purple dot at -2. So the red dot at 0, the orange dot at 3, the green dot at -1, and the purple dot at -2. I will make this an ed puzzle question. So what is C? What is the name of C? Extra credit. All right, so C is the y-intercept. Intercept. All right, and how do we find it algebraically? Which I don't want to do it, but I'm going to. And so how do we find the y-intercept at any moment? Ed puzzle question. All right, so we find the y-intercept when x is 0. So if I let x be 0 in all these problems, if I let this be 0, I get 0 squared, and that's 0. Oh, what is that? There you go right there. Look at there. If I say 0 squared minus 0, 2 times 0, 0 plus 3, I get 3. Well, look at there. There's 3 is right here. Wait, will you do that? If I say 0 squared plus 3 times 0, which is 0, minus 1, that's -1. Will you look at there? That's the y-intercept right there. And if I say 0 squared minus 0, that's 2, Mr. O'Neill. Get your life together. Minus 2, I get -2. Well, will you look at there? So I find the x-intercept when I find the y-intercept when x is 0. Let x equal 0. All right, keep it moving. And now we're going to deal with B. B is a little different. B tells you, if I may, say for instance, I wrote the equation as y is equal to, and I let that be 0. Y is equal to bx plus c. So what does this b represent? The b would be the slope. Okay, so if I took out the quadratic part, I never really said we have quadratic functions because of x squared. So that's the reason why it's quadratic, because x is being squared. I forgot to say that again. All right, so if we took the b out right here, we took the ax squared out, and we just looked at bx plus c. This reminds you of y is equal to mx plus b. where m is your slope. So b behaves as the slope. Watch this, y'all. So when y is equal to x squared minus 3x, so where the line, where the y-intercept is, the y-intercept of this red quadratic function is 0. At the y-intercept, it looks like if it wouldn't curve right here, if it didn't curve right here, then it looks like it's going to have a negative slope, hence that b is negative. So the orange line, the y-intercept is 3. So at the y-intercept of 3, again, it looks like I'm going to have a negative slope rising to the left. Okay, it's making more sense. I know it is. So at the y-intercept of -1, b is positive, so we're going to have a positive slope. Okay, if the line did not curve, it's curving because of the x squared that we are excluding. And now at this line, y equals -x squared, at the y-intercept of 4, if it did not curve, hey, this is a positive, so it's rising to the right. I almost made a little picture in there. So let me stress this, because I just took out a whole part y'all don't even know from the video to make this to make this a lot I guess, I don't know, easier for you all. All right, so we're saying that b acts like the slope. All right, it's acting like it's the slope at the y-intercept. So if b is positive at that y-intercept, that quadratic function, that part of the parabola, we will be rising to, is that y'all right? To the right. Okay. I think it's mirrored, so to the right. All right. And then if it was negative at the y-intercept, it'd be rising to the left. All right, so that is what we're doing. That's what b does. That's why I saved it to the end. It's not that that's hard, but you know, it's a little different. So let's review. So this is the big review, and all y'all have to do today is answer the questions in Floop, and I have a couple of questions for y'all. That I think, I don't know what I'm doing with my life. All right, so here we are. Y equals ax squared plus bx plus c. What is this? It is a quadratic function. Why is it quadratic? Because x is being squared, and it's quadratic because x is being squared. What do we call this? We call this the standard form. The standard form of the quadratic equation. And then the parent function will be y is equal to x squared. So what does a do? If a is positive, we have a parabola that opens up. If it's negative, we have a parabola that opens down. If a is greater than 1, we have a narrowing of the parabola, which represents a vertical stretch. If a is less than 1, as it becomes more and more less than 1, we have a widening of the parabola, which we call a vertical compression. Your b, if b is greater than 0, b is the slope as the function approaches the y-intercept. If b is greater than 0, man, I make some good notes. I have to put I really do the thing, y'all. I really do. I work. Yeah. All right. If b is greater than 0, then as the line approaches the y-intercept, it's going to look like a positive slope. It's going to look like it's rising to the right. If b is less than 0, as it approaches the y-intercept, it's going to look like a negative slope. It's going to rise to the left. C is the y-intercept. We find the y-intercept by letting x be 0. So if c is greater than 0, then we have a positive y-intercept. If c is less than 0, we have a negative y-intercept. And if we don't have a c, then the y-intercept would be what? 0. All right, that is the lesson for today. That is starting off. Things are going to get a little more difficult, y'all. So this just breaks down the quadratic function in the form of the parabola. And so I am done. There will be some questions in quizzes to wrap this up, to make sure that y'all understand what is going on. And you have those notes there. This has been another, I don't know why I came on the screen when I have to do this. Hold up, buddy. Don't play yourself. Don't play yourself. Play yourself if you want to. Beast Mode production. This is Mr. O'Neal. So grateful that you're here. I'm out.